Okay, so this is going to be the part two of IoT hands-on on TinkerCAD. We'll continue from where we left off. So we already have a circuit which is connected to the gas sensor, and we know that the gas sensor gives a proper range of input depending on the intensity of the gas that it has sensed. Okay, so according to that, we'll be lighting three LEDs, and there's just one slight correction. Now I have connected all these three LEDs to in a proper circuit, so even if we start it, all the three LEDs are going to light up immediately, so we don't want that, right? So what we'll do is we'll connect these LEDs to different pins on the Arduino, and we'll light them up depending on certain conditions, right? So first we'll take the green LED, and we'll connect it to pin number 8. Okay, that should be all. Okay, then we'll take the orange LED, and we'll connect it to pin number 7. Then we'll take the red LED, and we'll connect it to pin number 6. Okay, and just to make this wiring more clear, we'll change it to different colors. Let's say green one will be green, the orange LED will be orange, and the red LED will be, let's just make it brown. Okay, so for clear understanding. Okay, so now our LEDs are connected to pin number 6, 7 and 8, and our gas sensor is connected in a proper circuit, and it will be giving input at pin A0. Okay, so let's just write some code for this now. Okay, so first of all we'll declare all the variables for the LED. So constant int, uh, let's say green. Okay, green will be the variable for the green LED, which is connected to pin number 8. Okay, then we'll have constant int orange, which is connected to pin number 7, and then we'll have constant int red, which is connected to pin number 6. Okay, so now what we'll do is we'll light these LEDs as per the intensity. So if there is no danger, our green LED should light up, right? So what we'll do is we'll write a simple if condition for if our sensed is the final intensity value that we are getting after formatting the raw data, right? So if sensed is less than 10, we'll do digital write green to high. Okay, so what we'll do is if the sense data is less than 10, we'll turn on the green LED. Then if there's another way to write this all in just one line, we'll write digital write orange, and now we'll simply use a ternary operator where we'll compare the sensed value directly. If sensed is SEN SED If sensed is greater than 20, then return value high, else return value low. Okay, so this is simply if this condition is true, we'll get the first value on the left side of the colon, and if the value is false, we'll get the right side of the colon value. Okay, similarly for uh, ORANGE. Okay, similarly for digital write, red, if sense is greater than 80, then high, else low. Okay, so instead of making this 20, I'll just make it 40 because we have only 3 LEDs. And okay, so we'll just change this also. Digital write green, if sensed is less than 10, then high or low. Okay, uh, right, so this should work. So let's try and run this now. Okay, there is a error. I forgot to put semicolons here. Okay, two semicolons missing, one here and one here. Okay, okay, so we'll start serial monitor. Okay, so currently the value is 95, and our green LED is off, and our orange and red LEDs are on. Okay, so we'll just try to change this. Now if we take this away, so now the intensity of gas sensed is very low, that is 1. So our green LED is on and our orange and red LEDs are off. Now if I bring the gas cloud closer and the value is greater than 20, that is 23, let's say, so you can see our green LED is off, but none of the other LEDs are on, because our condition is if the intensity of the sensed gas is greater than 40. So now if I bring it closer and the intensity becomes 42, so our green LED is off, orange LED is on, and red LED is off. If we bring it closer and the intensity becomes greater than, it's now 76, if it becomes 84, so now you can see that the orange LED is on and the red LED is also on. Okay, and the green LED is off, which means the gas is too much. There's high intensity of gas and there is danger. So that's the complete circuit. There's one small interesting thing that we can add in TinkerCAD itself. So let's say if the red LED is on, we want a buzzer to buzz. Okay, so we can add a buzzer here. Okay, so now again the buzzer has 2 pins. So this time, instead of connecting the buzzer to a different pin, I'll simply connect it with the red LED. So I'll connect it across the same points as the red LED. So there's the high pin, yeah. So this will be the high pin for the red LED. So, and this will be the negative. So it is connected across the same circuit. So let's try and run this. So whenever the red LED is on, we should have a buzzer, right? Okay, so now the value is 84, so we are having a buzzer. I'm not sure if it is recording, but now there is only green LED, no buzzer, no orange LED, no red LED. If I bring it closer, greater than 40, now our orange LED is on, but red and green are off, and so no buzzer. Now if I bring it closer, our red LED is on, and I don't know if it's recording, but the buzzer is also ringing. Okay, so this is one thing that we can do, is we can attach more than one type of component with the same pinpoint, right? Okay, so that was a circuit for gas sensor. Okay, cool. So now we'll be doing the fourth and last experiment, that is the elevator circuit using Arduino. So let's take a new circuit and again we'll be trying to make this from scratch. Internet. Okay. uh, my dashboard, circuits, create new circuit. Okay, so in this elevator circuit, we'll actually be using a DC motor. And what concept we'll be using it when a person presses a button to go up or on the above floor. So the DC motor should turn clockwise for some amount of time, and after that amount of time, the DC motor should stop turning, which means the person has reached the above floor. And if he wants to come down, the DC motor will have a different button to denote that the person wants to come down, and the DC motor should rotate in the opposite direction, that is anti-clockwise. So for this circuit, what we'll need is we'll need an Arduino board, obviously, because that's what we are using for the logical part. Then we'll need a motor. Okay, so we have quite a few options for the motor, but for this experiment, we'll be using a DC motor. Okay, and we'll also need buttons, right? So if the person wants to go up, he should press the up button. So we'll take a simple push button. Okay, and we need two buttons, right? One for going up and one for going down. Okay, so one simple briefing about this push button. What happens is when you press on this button, it sends a it completes the circuit. We connect this push button across a proper circuit. One is connected to ground and one is connected to some pin. Okay, so whenever we press the button completes the circuit and we get a high value. Cool. So we'll first make the connections. Now we have to connect the DC motor across two pins. One is terminal 1 and terminal 2. So since the DC motor works on direct current, what we can do is we can simply switch the polarities of this motor to make the motor turn in opposite direction. So let's say we give terminal 1 as positive and terminal 2 as negative. So the motor will turn anti-clockwise. And if we give terminal 2 as positive and terminal 1 negative, the motor will turn clockwise. Okay, so we'll first simply connect this to, let's say, pin 2 and 3. Pin 2, and our other terminal will be connected to pin 3. Okay, just to avoid confusion, I'll change this. Come on. Okay, just to avoid confusion, what we'll do is we'll give the leftmost pin in pin 3. Again, we'll give the rightmost pin on pin 2. So the circuit wiring is easy to understand. Okay, we'll change the colors. We'll keep this, let's say, brown, and this will keep as purple, just because. Okay, now we have to first, before we connect the buttons, let's just see if we can actually turn the uh, motor in clockwise or anti-clockwise direction. Okay, so we'll write a small code again. Let's go to the coding section. Text. Okay, now we will specify constant int motor. Now if you look closely, we have two colors in the motor pins. One is black and one is red. So just to keep it simple, we'll specify it as motor red. and motor red is equal to pin 2 in constant int. Constant int motor black is equal to pin 3. Okay. Now, simply both of these pins are going to be output, which means we can specify them as either high or low. Okay, so pin mode motor red will be output, and similarly, motor black will also be output. And right now, we'll not print anything in the serial monitor. Okay, so we'll do is we'll just okay. Now, what we'll do is we'll try to rotate it clockwise. So for first, what we'll do is digital right motor red is high. Okay, and digital right motor black is low. So what this will do is this will send a high voltage to positive voltage to the red terminal and no voltage to the black terminal, terminal 1. And we want this condition to be kept for delay equal to, let's say, 10,000 milliseconds. Okay, so that's probably 10 seconds. uh, Now what we'll do is after this we want the motor to stop, so we'll make both of them as low. Okay, and after this I want again a small delay of, let's say, 5000 milliseconds, and after that I want it to turn in the opposite direction. So what I can do is I'll just make the motor black high and motor red low. So this is the exact opposite polarity of the first condition. Okay, and then again we'll keep this for 10,000 milliseconds. Okay, so let's see if this is working. Okay, so now you can see what is happening. So the motor is rotating in clockwise direction first, then it's stopping, and then anti-clockwise. Okay, so the motor is working now. We just want to make this motor turn on when the buttons are pressed, right? So what we'll do is we'll specify constant int. First we'll make the connections of the buttons. Okay, so again the button has to have a complete circuit, so it will once it will be connected to one terminal will be connected to ground, and we'll make it the up button, and this should be the down button. So one terminal is connected to ground, we'll make that black, and its terminal 2 will be connected to, let's say, pin number 12. Okay, we'll make this red, and the terminal 1 of button 2 will also be connected to ground, we'll make that black, and the other terminal will be connected to, let's say, terminal 10. Okay, So button 1 is the button to go up. I'll just make this red. Okay. Button 1 is the button to go up, and button 2 is the button to go down. Okay. So I'll just specify button button up is connected to pin number 12, and constant int button down is connected to pin number 10. Okay. Now these are the pins in which we are going to take input, right? So we have to specify pin mode, button up as input, and button down also input. Okay. So now we'll just make these conditions on certain place. So now what we'll do is I'll just make some space here first. uh, Status, int status digital read button up. Okay, so what will happen is when the button is pressed, our status, come on. Okay, so when the button is pressed, the circuit will be complete, and we'll get the right. So button up. So if okay, what we'll do is we'll take this as the up button. If up is equal to 1, it means the motor should run clockwise to go up. So I'll take this. Okay, and after the motor is turned for some time, we'll again stop it. So digital red I. Okay, and we should also check int down. Down digital read button down. Okay, if if down is equal to 1, and what we'll do is we'll take the opposite thing. So I don't need this now. We'll take the exact opposite. So up we had red high and black low. Here we should have black high and red low. Okay, then we'll have a delay for 10,000 milliseconds, and again. Okay, so here I forgot to change this to low. We'll change this to low. Okay, this should work. Let's see what else are we missing. Let's just think before we run this code. So we are taking input from up, taking it down. Hmm, there's obviously better ways to write this code, but this is the most easiest implementation. So what we'll do is, okay, one thing we can do is initially we can keep up is equal to 0 and down also is equal to 0, so there's no confusion. Okay, and okay, let's see if this works. So we'll start the simulation. Do we have any errors? Okay, no errors. So let's try and press the button. If I press the up button, nothing happens. Hmm, what am I missing? What am I missing? Okay, okay, there's one thing I think I'm missing. For buttons, there's input pull up. Let's see if this works. Okay, okay, cool. So I forgot one thing. So for push button switches, we don't write input directly as in pin mode. We have to specify that the button is a push button. So we write input underscore pull up. So every time after pressing the button is to be automatically pulled up, right? So now it's working. So now I have pressed the up button and it's rotating clockwise. Cool. Now will it stop? Okay, it stopped and it is rotating anti-clockwise. Why is it rotating anti-clockwise? Mhm. Okay, I think low, 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 low. Okay, what's wrong now? Um, I press the up button, it is changing direction directly. So here I have digital right motor red high, digital right motor black low. This is making it run clockwise. Then we have a delay of 10,000 milliseconds. We write motor red low and motor black also low. Okay, I'll change this to else if, and instead of writing this here, we can do is we can write an else condition. So else both the motors should be at low. Okay, Let's start and check this if this works. Okay, so the motor is on directly. Heck. Okay, so now we need to debug the code. Let's see how we can debug the code. We have to check what are the values of up and down. Okay, so we'll first start serial monitor, serial dot begin at 9600. Now what we'll do is we'll print the values of serial dot println up, comma up, and serial dot println down, comma down. Okay, let's see. No matching function to call. Oh, sorry. So we can't write it directly, right? We just try to keep this. Okay, now we'll check the serial monitor. Okay, so even without pressing the buttons, the value is up. Y. Um, okay, so it's continuously coming as 11111. Mm, I've specified button up and button down, input pull up. Okay, so what could be the issue? We have void setup, motor, red, high, low, digital read. If the button is pressed, so when are we pressing the button? What happens if we press the button? Am I able to press the button? Okay, so we got a zero somewhere. Mhm. Okay, let's just check the buttons first instead of running the motor. Okay, so what we'll do is we'll check the buttons one by one. We have int up and down, and we'll just check the is button one. So we start simulation. Initially the value is continuously 1. Now if I press the button, we get the value as 0 for 1 second. Okay, so if we press the button, the value is 0. Okay, this is actually just inverted. So what we have to do is, um, it gives us value 0 when it is pressed. Okay, cool. So what we'll do is, instead of uh, rotating the motor when the up is 0 or 1, we'll make it to up is 0. If down is 0, we'll make the motor run down, or it will just uh, say like that. Okay, so we have values 1 and the motor is not running. Now if I press the up button, the motor is running clockwise for 10 milliseconds, and then it should stop. Let's see if it stops. Cool, it stopped. Now if I press the down button, the motor is running anti-clockwise, and it should stop after some time. Let's say if it stops. Cool, it's stopping. So our elevator is complete. If you press the up button, the elevator goes up. If you press the down button, the elevator goes down. Cool, so we'll just add one small thing in this circuit, and just to make it more user friendly. Okay, so people are not going to check whether the value is 1 or 0, right? People need some visual indication. Okay, so before we do that, let's just read if we have any questions in the comments. Okay, Pragati says your explanation is awesome, sir. Thank you very much. Rajkumar says great project, sir. You are most welcome. Okay, so one last thing we'll do is, so whenever we are in a lift, it's really good to see if we are going up or down, and instead of seeing the numbers, it is better to see some light bulb light up or some LED light up. So we can also make this light bulb, but for now we'll simply make it an LED. Okay, so what we'll do is, uh, whenever the motor is going up, the the up LED should turn on. Whenever the motor is going down, the down LED should turn up. So we'll have two LEDs. Okay, instead of LEDs, I think we have a bulb here. Cool, so let's see if we can connect this light bulb here. Light bulb, come on, light bulb. Okay, cool, so we have one up light bulb and we have a down light bulb. Cool, so where should we connect these bulbs now? Okay, so obviously that has two terminals now. So one terminal is to turn it on and off, and the other terminal is to be connected to the ground, right? So we'll connect the right terminal to the ground. This is going to be, this is going to look a little shabby, but we have to connect wires like this. Okay, or we can simply use a breadboard, but right now we already have a circuit, so we'll simply connect it to wires. So this is going to be the ground. This shall also be the ground. So instead of connecting it here, we'll connect it from the right. Okay, so where to connect the positive terminals now? So there are 2 points where we can connect the positive terminals, either with the switches or with the motors. Now I would prefer to connect it with the motor, because uh, it should be on till the motor is turning, right? So I'll connect the down bulb with pin 2, and we'll make this red, and the up bulb with pin 3. Okay, cool, so we'll make this also red. Okay, so this should work whenever the corresponding pins are high. We'll change this green to black. Cool. So we'll start simulation and let's see if this works. So if I press the up button, is the motor turning? Okay, so both the bulbs are high. Mhm. I press the down button. Again, both the bulbs are high. So why is that? Let's just check the code one last time. Mm, If up is 0, it will write motor red high. So when motor red is high, motor black should be low. So this should actually be low, but why is it showing high? Hmm. Mhm. Okay, we are going up, and after some time, are we going to stop? Yes, we are going to stop. And if I go down, motor turns again. Now we're going to stop. Yes, we stop. So you know what, I am not going to solve this problem. I will be leaving this problem for you. Connect the two bulbs in the circuit in such a way that when I press the up button, only the up bulb light bulb should light up till the motor is turning clockwise, and when I press the down button, the lower light bulb should light up till the motor is turning anti-clockwise. Okay, so let's see if you can make that happen. So that would be the last experiment for today, and I hope you guys have understood and you should try it. And if you have any doubts or any comments for my teaching or the circuits that I've built, if I could have made a better circuit or written a better line of code, make sure you mention it down in the comments, and let's see if you can teach me something I'll learn. That's great, right? So I hope you guys have understood and liked the video. If you like it, like the video and share it with your friends who need to learn more about making virtual circuits on tinkercad. So that would be the end of this live stream. Thank you very much.